Okay, here's a practice problem. This one's from page 867 in your book. Okay, just a simple little redox reaction, a synthesis here, putting them together to make ethane. So they give you the enthalpy value, they give you the entropy value, and they give you the temperature that the reaction is, proceeding at. Couple of things: make sure your temperature is converted to Kelvin. Also, notice the delta S value and the delta H value, so the entropy and the enthalpy values. One is kilojoules, one is joules. Make sure they're both in the same unit. Okay, so flip them both to joules or flip them both to kilojoules before you proceed through the problem. Okay, then three things we want to do. We want to find the delta G, so we want to find the Gibbs free energy for the reaction. We want to decide, is it spontaneous or not spontaneous? And then if we increase the temperature, what happens to the Gibbs free energy? So first thing, set the formula, delta G equals delta H minus T delta S. Plug in the values. Notice I changed kilojoules to joules. So we got the negative 137,500 joules minus the 298 Kelvin times the negative 120.5 joules per Kelvin for the entropy. Then it's plug and chug. Use your calculator, get the delta G value. So around negative 101,000, a little more than that. If delta G is negative, okay, if delta G is negative, that means the reaction process is spontaneous, okay, that it's a spontaneous process. Okay. If it's positive, then it's not spontaneous, okay. So what happens to the Gibbs free energy if we increase the temperature? Just pick an example temperature greater than 298 Kelvin. So I chose 315 Kelvin. Use the same equation. Put in 315 Kelvin instead of 298 Kelvin. Solve, and we see that we get like negative 99,542.5 joules. So it's not as negative. Okay, it's not as negative. So what happened? Delta G decreases, less free energy to use and to do work, which means it's less spontaneous. Okay.